Good morning, good afternoon, or good evening to all of you on the webinar today. My name is Louis Carr, and I'm the Senior Director of Product Marketing at Actian, and I'll be acting as the moderator for today's presentation by Bill Inmon. It will be Rethinking Cloud Data Warehouse Integration. And as all of you know that have joined, Bill Inmon is largely seen as the father of data warehouses. At this point, with no further ado, I'm going to turn it over to Bill. But before I start, please, if you have questions, place them into the question and answer section. And we'll try to get to all your questions, but we'd like to save the questions until the end of the presentation. If we can't answer one of your questions during the webinar in real time, please leave your email address and we will follow up with you. We want to make sure and answer everyone's questions. So with that, I will now turn it over to Bill. Bill?
Thank you, Louis. First off, it's a real pleasure to be here and talk with you today. I hope to make this an interesting conversation. I want to talk today about transformation. Transformation is a human activity that we all do. We may not even know we're doing it, but we all do it. So let me just talk very briefly about human transformation. Suppose one day you're doing your checks at your desk and you get a check from Canada and you get a check from Mexico. What do you do with those checks? You don't just take the checks and add an amount into your checkbook, into your bank. What you do is you take the amount of money that's on the check and you transform it. You transform it from either Canadian dollars or Mexican pesos, and that's what you put into your bank account. So transformation is something that we do every day of our life without even thinking about it. And when data warehousing first came about, the notion of transformation was not really associated with the computer. You see, we had in the early days lots and lots of application systems. And each application system had its own interpretation of whatever it was that it did, and it was its own unique application. And then we had another application that was its own unique application. And that was fine. That worked pretty good, and people were happy with the applications. Until one day somebody came along and said, gee, I want to take information from each of these applications, but I can't because data from one application is not compatible with or in sync with data from another application. And so when we go into the world of data warehousing, we have this whole notion that we do transformation. That there's actually a lot of things data warehouse does for you, but the whole notion of integration and transformation is one of the major features and functions of data warehouse. Now let's talk about going to the cloud. When it comes time to take our data and information into the cloud, do we somehow magically not need to transform our data? And the answer is no. Then there's a need for transformation of data wherever you're at and whoever you are. And going from the on-premise databases and applications we have to the cloud does not mean that you don't need to do transformation. So ETL is the tool or the acronym for the tool that we have for doing that transformation. Now, just in case you've never been exposed to it, ETL refers to extract, transform, and load. And that's the whole notion of a computer explanation of what we mean by transformation. So let's go ahead then and start today's presentation on on ETL transformation in the cloud. Next slide. Um, so in the beginning, there were these base applications. We had all kinds of data that's out there in all kinds of places. And so we then wake up one day and have a need for looking across all of the data. And that's what ETL is, and that's the driving force behind it. If we didn't have a need for looking at information on the across the enterprise, we wouldn't need ETL. But that's not the case. Organizations everywhere have a need for looking at data on an integrated environment. Now, by the way, before we get started in terms of terminology, I'm going to be using some terminology that you may or may not be familiar with. There's really two kinds of data in the corporation. There's application data and there's corporate data. Application data refers to the data that the application designer builds and uses and manages. And each application has its own interpretation and its own form and structure of data. Corporate data, on the other hand, is data that is used across the corporation and is used by everybody in the organization. And so there is then this fundamental difference between application data and corporate data. Next slide, please. Next slide. Okay. So in the early days, and boy, when I look at this slide, this really was the early days. Some of the early types of data that we have were things like IMS, MVS, and COBOL. That was a long time ago. VSAM, CICS, and Assembler. We had IDMS, MVS, and PL1. We had Oracle, NT, and PLC. And these were some of the earlier applications that we have. The base technology is very different. The dates, the technologies are acquired are very different. There's lots and lots of differences between these environments. And every difference is another reason why people had such a difficult time trying to understand data across the corporation. Next slide. And so what we find is if we start to just willy-nilly take the data out of these applications and try to add them together, it doesn't make sense. It's trying to adding how many bananas do you have to how many apples do you have to how many oranges do you have. Does that make sense? Well, I don't know, maybe it might make sense, but not very much sense. That you want to know on a unified basis how much you have. It's kind of like saying in our example that we talked about, taking Mexican pesos, American dollars, and Canadian dollars and mixing them all together. And without transforming those values, the answer we come up with doesn't make a lot of sense. Next slide. And so we have then technology that we use to make the transformation from one application into a corporate mode. And that technology is something called ETL, Extract, Transform, and Load Technology. It's the technology that goes through the logic of what does the application look like and what does the corporation need. And it makes the transformation in such a fashion. So that's the technology is called ETL. Now, do we need ETL in earlier applications? Yes. Do we need ETL in the world of the cloud? The answer is absolutely yes. The need for transformation does not go away by going to the cloud. And by the way, don't let a vendor, vendors of the world try to talk you into things that sometimes don't make sense. And so don't let a vendor of the world say, well, gee, you go to the cloud and magically all this stuff goes away. That's not true. That the need for transformation is as strong in the cloud as it was anywhere else on this earth. Next slide. And so, how did this ETL thing happen? Well, I was in the early days of data warehouse. We built ETL manually. We had programmers writing code, and we had programmers sitting there churning this code out. And one day we noticed something. We noticed that the code produced by each programmer was essentially the same thing. Now, there were always, obviously, a few differences, but for the most part, it was a simple matter of going into an application, finding the data you're looking for, transforming it, and putting it out into a standard data warehouse. That's what ETL does. And we found that the code that was being produced by the programmer was the same thing over and over and over again. There was very little intellectual difference between one manually produced ETL program and the next. And so along that line, I don't know who it was that noticed it, but along that line, somebody said, gee, maybe we should have a program that does our ETL processing for us. And so, and why? Because writing ETL programs day in and day out is a fate worse than death. I often thought that if somebody wanted to put me in prison and drive me crazy, they would say, Bill, sit here and do nothing the rest of your life but write ETL programs. Well, I would go crazy. I don't know, maybe a week, maybe 2 weeks, but somewhere along the line, I would sit there and say, I can't do this anymore because it's the same program over and over. Next slide. So along that line, one day, the idea came up that we should produce this code in an automated fashion. That if it's going to be the same program over and over, why not just create a program to automatically create and manage and build that code for us? And so that's how ETL got started. Now, in the very beginning, the ETL programs were really rather quite simple, but as time has gone on, the ETL has become much more complex and much more sophisticated, as you would expect. Next slide. So that then is the origins of the world of ETL. And today, ETL exists as an industry. Once upon a time, it was not an industry. It was just a bunch of people creating code. Next slide. So when we talk about ETL, what are some of the features of ETL? First off, a consistent structure is produced and the content is produced in a consistent fashion as well. Let me give you a quick example of this. Suppose we had some applications, and one application refers to a person's gender as male and female. Another application refers to a person's gender as an M and an F. Another application refers to gender as a 1 and a 0. Another application refers to gender as an X and a Y. Well, those are all legitimate forms of referring to gender, but they're not the same thing. If we tried to bring this data together and do analytical processing on it, we would have a difficult time. So what do? We say, okay, the corporate standard for gender is going to be, say, M or F. And so we then go back into the applications, and where gender is represented by something other than an M or an F, we make the conversion. Now, that's a simple example. In truth, the transformations that we do for data warehousing are much more complex than that. But that's the idea of going from application data to corporate data where there is a single understanding of what that data looks like in the in the corporate world. Next slide. Um, the second nice feature of ETL is once you have your technology in place, the code can be produced very quickly. How quickly? Oh, I don't know. Depends on your ETL and how much transformation you've got to do, but anywhere from 2 to 3 seconds to maybe 60 seconds at the outside. And no programmer on earth can program as quickly as ETL can bring the code to life that you need to have brought to life. Next slide. Um, the Another nice feature of ETL is once you've got the transformation rules captured and put in the code, being able to go in and maintain the code quickly and accurately becomes easy to do. And by the way, trying to do any form of maintenance easily is a real trick. I don't know if you've ever tried it before or not, but it's not easy. Next slide. For these reasons, then, the automated production of the code is by far the most popular choice. The only time I've had people say, gee, Bill, can't I just get a programmer and create my ETL code? Yeah, you can. And when would I recommend that? Well, if you only have a total of 5 programs ever to be written, then maybe doing it manually is an okay idea. But if you have anything more than 5, and almost everybody does, that is when you need to start to think about having an automated means of producing your transformation code. Next slide. So then there are 2 forms of ETL code that are produced automatically. Next slide. There are many different types of data that can serve as the source of data for ETL processing. And one of the problems is that there are many forms of data. Data, I don't know if you ever thought about it, but data can actually take many forms. It's not like there's one form of data that we keep everything in. That simply is not what people do. There's many forms of data that's out there, and ETL has got to be able to accommodate all of those different forms of sources of your source data. Next slide. Any one aspect of ETL processing is not difficult, but ETL processing is difficult because of all of the things that have to be done. So you can say, gee, Bill, gender, if all I have to worry about is transforming gender into a common way of looking at gender, how difficult is that? Well, it's not difficult. But what if you've got 100 other things that at the same time in the same program have got to be taken care of as well? Then all of a sudden, even the simplest task in the face of something times 100, it becomes difficult to do. So it's not just the fact that any one transformation is difficult, it's all of the transformations taken together and to be done all at the same time is where the difficulty lies. Next slide. So you say, okay, Bill, thanks for telling me all this. What exactly do you mean by transformation? What takes place as we do transformation? So I'm going to go through some of the things that take place when you do transformation. Number one, you've got to look at different types of records. You've got to look at human resource records. You've got to look at inventory records. You've got to look at sales records, and that's difficult. Number two, sometimes you end up summarizing data, that the data that you're reading at the source level is so detailed that it needs to be summarized. Another thing that is very, very common is you need to resequence the data, that the source data comes into you in one sequence, but In terms of what it needs to look like when you put it in the output side, it may have a different sequence. Now, resequencing data in some cases is very easy to do, but resequencing data in other circumstances can actually be quite tricky to do. Along that line, another thing that you may need to do as part of ETL processing is to alter the key structure, that you have your source data coming in with one key and going in the output side with an altered form of the key. So that's another thing that needs to be done. And again, any one of these things is not particularly difficult, but all of them taken together, the task becomes very difficult. Next slide. Uh, Continuing our example of what needs to be done during the process of ETL, reformatting data, that you have data coming in one format, you have it going into the corporate world in another format. Another thing is adding default data, that on occasion you know that you have data that you need on the output, but there's no source for it. So in that particular case, you've got to create and understand what default values are the appropriate values. Another thing that needs to be done is adding an element of time. The data comes in on the source side with no element of time, but in your data warehouse, you need to have some element of time there so that the values that are representative are relative to some one moment in time. And that's another thing that needs to be done. Another thing that very frequently needs to be done is changing DBMSs. You have data coming in as an IMS file, and it's being written out as an Oracle file, for example. So that's another thing that needs to be done. And again, none of these things are terribly difficult until you try to do them all together. Next slide. Continuing our list of things that need to be done is at some point in time, we need to start to gather metadata. Metadata has got lots and lots of purposes, and I'm not going to go into what those purposes are. I'm just going to say there's a lot of reasons for gathering and storing metadata. And at the moment of taking text from the source world into the data warehouse world is a very good time to find and collect the metadata that you're needed. Using logic to alter data, that's another thing that needs to be done. Automate the process of maintenance. That's another thing that needs to be done. And again, all of these things taken together mean that the process of transformation is a challenging process. Next slide. So another thing that an important thing is dealing with the volume of data. Now, a lot of people just have a modicum of data and they don't have that problem, but other people have got a huge amount of data, and the sheer volume of data becomes another factor that's got to be taken into account by the world of ETL processing. Data cleansing, at the point of putting data into your data warehouse, data cleansing is something that is very good activity to do. Next slide. And so you're probably getting tired of me talking about all of these things that need to be done. And I'm getting tired too of listening to myself talk, but all of these things are important things, and they've all got to be done at the moment of ETL processing, and they've got to be done all in concert with each other. So then we see then ETL processing is an essential part of the data warehouse environment. And it doesn't matter whether your data warehouse environment is on premise or whether it's in the cloud itself. It's simply a fact of life that transformation has got to be done. Next slide. So that then is some of the advantages of ETL. Complex transformations can be handled, and there's a lot of advantages and disadvantages. and you can read them here as well. Next slide. Uh, ETL. Oh, I think I'm traipsing on your slides. Are these your slides, Lewis?
Yes, they are. I added those in to make sure that with the examples that you gave, Bill, for when and how and why you would use extract transform load. I wanted to make sure that those in our audience that have heard a very similar term of extract load and then transform understand what the differences are between the two,
Okay,
and when you would use them. So if you look at the possible advantages and some of the possible disadvantages, you can see that they're quite complementary. And then if you look at some of the use cases, again, there is a level of complementary that is really important to be aware of.
absolutely. Okay, well, in that being the case, I'm going to turn the program over to you.
Okay, so for those of you out there, please put your questions in. I'm going to take just a couple of minutes to allow you to collect your questions. And I want to bring together some of what Bill said. As he mentioned and reiterated several times, everything that has happened with ETL, extract, transform, and load, um, has taken place over the last 4 decades. The move to the cloud does not remove or alleviate the need for data integration and the fundamental underlying ETL process. In fact, there are really three key data integration trends in the cloud era that will mean that it's even more important. The first is that cloud introduces new data silos. And I'll briefly talk about that for a moment here. The second is that the reason I was doing that compare and contrast of ELT and ETL is that what you're going to see, we believe, is a convergence of those two, which are often separate platforms, into a single platform. And the last and most important is, with all that myriad of use cases that Bill just showed you for the different reasons that one would need to use ETL, and the fact that those reasons are not independent, that generally there is a combination of those uses that's necessary, um, isn't going to go away. The key difference, though, is although Bill mentioned that, hey, you don't want to be doing the coding and you want to automate what you're doing with that ETL process, the fact of the matter is, up till now, all that's happened is you've moved to higher levels of coding, leveraging more sophisticated tools. But the level of sophistication that you need in order to use those tools means that it's an area of specialization that has been largely relegated to IT professionals. And so what we expect to see is a move increasingly to power users having to a need to collect that data and integrate it themselves. And so the way the tools are used and the expectations of how simple they are to use them is going to shift. So for those 3 points, very briefly, the fact of the matter is that to date, 80% of the time, and this is a Gartner figure, 80% of the time, um, the business analysts, the developers, the data scientists, the engineers, the people that actually that data and use that data, are finding most of their time is spent on the data preparation and the quality. So in ETL terms, that ties into, oh, the data's coming in and it needs to have a time series stamp. Oh, the data's coming in, I need to make sure that I'm doing the proper enterprise governance. I'm making the right conversions to handle the gender example that Bill gave. And of course, there are equivalents, an infinite number of equivalent examples. The other issue is that, as I mentioned, the cloud has simply introduced new silos. While you can't see my picture, I've been around in the industry for quite a long time. I can remember 20 years ago at Sun Microsystems, we talked about really what at the time was the beginning of the cloud. And now, of course, we all know cloud. And at that point, there were these big monolithic apps that were at their zenith. Siebel for CRM, or PeopleSoft for HR, or SAP for supply chain management. And over time, those platforms have now migrated to the cloud. They might be in the form of a new vendor, maybe Salesforce for CRM or Workday for HR and so forth. But effectively, all that is happening is that each of these departments, HR or sales or marketing, have all gravitated to these new um, new applications with their own embedded databases, or the need to have them work with a database externally, or to send data to the data warehouse. The upshot is that you end up with the same need for the same ETL processes and ELT processes that you had before. Data lakes, data warehouses, all of the architectures and the features and functionality that are needed and of course drive the use of those architectures has simply moved to the cloud, and with it the expertise and the requirement for that expertise of using IT has moved along with it. And what this simply means is that we're just having a repeat of what we've had in the past in terms of use of these systems. And so what we believe is that over the next successive generation in the cloud of these what were on-premise architectures, yes, they will first begin to be re-architected so that they can use the economics of the cloud, so that they can virtualize, so that they can spin up and spin down in terms of use of resources, and allow for use of those resources by more in users concurrently, for example. That is only part of the issue. The other part of the issue is being able to leverage those systems directly. And for that to happen, you have to look at the features and functionality leverage and how it's tied to each of the key architectures. So the first one is the data hub. There are certain things in a data hub that are critical, that are used, that are important, that need to be carried forward into whatever that next generation is. So that might be the fact that with a data hub, I'm doing that ETL, that complex process across a lot of different data sources, and I'm able to handle those data sources in different velocities and different formats. So I might be handling them in batch or streaming or both. I might be able to do the data preparation and quality, but in that particular case, it's always a way station that's ephemeral. That is, the data itself has to persist somewhere else. So on the other side of that data hub, there's always the expectation that I have a database or data warehouse or a data lake, right? So we know that that while there's only two types of data, as Bill said, application data and data that is the corporate data. What's defined as corporate data has changed. The corporation might not own that social media data, but it's vital to their ability to act as a corporation for something like, let's say, customer sentiment analysis. That corporation data may extend to their business partners for, let's say, supply chain and demand forecasting. I could go on, but that list means that I've got all these different types of data, and the data warehouse or the series of databases that may have handled that traditional application data and corporate data has to be expanded to handle different forms of data, as Bill talked about. Well, that's what the data lake over the last 15 years has begun to handle. The problem with the data lake, just like with the data hub, is that it requires direct IT support and use. The data warehouse, of course, has always been, that's been the case, as Bill would attest to. The other thing with the data warehouse is changing how much data has to be put into them. And then finally, I would say the analytics hub, which is becoming much more of a popular uh, destination or tool to be used by data scientists and even power users that have a background in data scientists or work with the data scientists. And in their case, it's very similar to the data hub in that the data is being brought in specifically for a particular project. It's not necessarily that common operational picture, that long-term persistent placement of the data in a location and in a fashion where multiple users across multiple departments and roles can use that data. So um, the point is that what we're going to have to see is some combination of those features and functionalities from those four architectures. And the other issue is that a lot of the tools have to be brought together as a single set of tools, regardless of which of those particular platforms you're talking about. We have a product called Avalanche, which embeds its own data integration into it and is beginning to move towards that next generation of real-time connected data warehouses. And the point of that is simply so that I can really not necessarily remove completely IT, but enable IT to deal with the fact that they simply don't have the bandwidth, and as a result, because they have to be involved with that data preparation, with that data access and ingestion into the repositories that feed the tools that are used by the business analysts, the data scientists, etc., that we need to somehow reduce their activities and efforts and support for those tools such that the data scientists and business analysts can use them themselves, and they can use them across the myriad of platforms that are currently siloed. So for example, if I have data generated by the Salesforce going into an app like Salesforce, data generated by marketing that's going into a tool like, let's say, Marketo, and then all the data that's spread across all these different organizations that's effectively in something we call pickup files, right? That data also can be paired, combined with the data from these large enterprise SaaS apps, and that the unification of that data, placing it in a common operational picture, can be done by somebody that has a background in the space but is not sitting in IT, so that in fact the line of business can work with other lines of business to provide that unified view, that unified view of the data can then be placed in a fashion that it is consumable and understandable to glean the right insights at the middle and higher management levels up to the CXO. And so that's where we see the three trends for data integration going. And with that, I'm going to move over to questions. So I'm going to, Bill, ask you a question from one of our listeners. The question is as follows. Once data has been moved to a data warehouse, how do end users query it without knowing the structure of the data warehouse, which is beyond the realm of most potential end users?
The way most people do that is to do it indirectly. Most people take the data from the data warehouse, put it into a cube or some form of data march technology, and then do their querying at that level. Now, these things called data marts that people create are typically suited for some function. You have a marketing data mart, you've got an accounting data mart, a finance data mart, and things like that. So now can you actually go in and query a data warehouse? Yes, you can. Do most people do it that way? I don't know, maybe a few people do, but at least the one people I talk with, most of them do not do it that way.
Okay, and then the next question is, how does a data lake differ from a data warehouse?
Okay. In order to answer that question, I've got to take you back through a little bit of the history of big data. A while back, the world had put in front of it the concept of big data. Now, big data was something that big data was sold, whether the vendors admit this or not, it's the truth. Big data was sold, gee, you put your data into big data and you don't need a data warehouse and you don't need all of that messy analytical stuff that people are all the time doing. And so that's how big data was sold. And then once people started to actually use big data, they say, gee, I find it very difficult to actually use the data in big data. That's where the notion of a data lake came from. They said, oh, at that point in time, the vendors of big data discovered that they needed to have an underlying architecture. So Rather than have an architecture, somebody came up with the idea of, oh, let's just call it a data lake. And what is a data lake? A data lake is simply a place where we throw all this data and then hope at a later point in time somebody can find things and come along and use it. It was in essence not an architecture at all, and so that's where data lakes came from. And then people started to put data in this data lake, and they discovered, oh my gosh, I really can't use this data. I can't find anything. I can't put anything together. It's very difficult to use. So the solution for this was something called the data scientists. It's, oh, well, what you need are some of these data scientists. And so they brought these data scientists in and they paid them huge amounts of bucks. And the data scientists turned into, I always called them a data garbage man. That they were hired for all of this technical expertise they had, and 98% of their job was out grubbing through data that should have been organized in the first place. So what the world has discovered is that when you have these data lakes, it's not enough just to put the data out there and hope that somebody can look at it and use it. You've got to put, there's several things you need. Number one, you've got to have metadata. If you don't have metadata, you're lost, number one. Number two, even if you have metadata, you still got to integrate the data. That you just can't take dollars and pesos and Canadian dollars and add them together. Or yes, you can add pesos and Canadian dollars and American dollars together, but you end up with nonsense. You end up with something that doesn't make any sense at all. So, in order to make the lake house, the data lake viable and useful, you've got to, number one, put in metadata. Number two, you've got to go in and integrate the data to make it to where it can be used. And people are just now discovering that. And I think the irony of ironies is company after company was sold on the fact that, gee, when you go into this big data thing and this data lake thing, you don't need all this complex stuff. Guess what they're finding out? Yes, you do need all of this complex stuff if you're actually going to make sense of the data itself. So that's a little bit, and in concert with what Lewis said a little bit earlier, that ETL and ELT are going to converge over time. That's the convergence that we are starting to see. It's not there yet, but it's getting there.
So while we're talking about the differences between a data warehouse and a data lake, Bill, another question that's very similar to that, so I may as well ask it now before I move on to the other questions, is how does a data, um, what, there's a new idea. It's called a lake house, and the questioner really is asking: is this going to be the follow-on to data lakes? Is this something different? Is it combining the two? What are your thoughts on this whole concept of a lake house?
I think it's kind of interesting that every time we walk down the path of big data to a data lake to a lake house, every time there is a problem, somebody invents a new term, and in reality, a data lake house is just the next step towards the convergence of a data warehouse and a data lake. And one of these days, you won't be able to tell the difference, but today you can. So a lake house is merely the next step in the transformation of raw data into something that can be used and looked at and understood.
Right, and you mentioned that one of the key things is that you want to balance, how you're dealing with the need to handle structured data versus unstructured, and one of the key things is that metadata being the bridging piece. I've got another question here. Um, which maybe I shouldn't have added those slides in because it's certainly piquing everyone's interest. But the question is essentially asking, I understand the need for ETL, but not the need for ELT. It would seem to me that ELT should not be done, and instead it should always be ETL. Can you explain the need for ELT?
Well, if the my understanding of the original notion of a data lake is you just throw a bunch of data out there into the data lake and hope somebody comes along and looks at it. That's my understanding of what happened. Uh, what do you have to do to that data that's just sitting there? You've got to do something to it. That's where ELT comes in. So ETL is what you do to get data in a data warehouse. ELT is what you do to start to straighten out your data to where it can be useful. So um, uh, people that sold big data for whatever reason didn't like the idea of ETL. It was messy, and I, I can understand that. Why? Because integrating data is a dirty job. I think of a car mechanic with oil all over his hands and grease in his hair and mud on his face. To me, an oil mechanic is the same person or type of person that does integration of data. There's doing integration of data is an essentially dirty job. It just simply is, and I don't think there's any way around it. And so when people were attracted to big data, the big data vendors came along and said, "Oh, look at this! You can buy big data, and you don't have to do any of that dirty old integration stuff again." Well, they sold people on that. And then they woke up to find out, oh my gosh, we really do need that integration stuff. So that's where ELT comes in and is very much a place for it. If you're just going to throw data out into a garbage pit, if you're going to make anything out of your garbage pit, you've got to go use ELT to get it done.
Yeah, just to, want to add on to this answer for the gentleman in our audience that asked it, and say that, although it's not the purview of the topic that we're talking about today, another reason that you might want to consider ELT instead of ETL is that, in the traditional client server model, or the cloud virtualization of it, you basically have the application and you have the data warehouse. But quite frankly, increasingly the origination of the data, the source of the data, is really sitting out at the edge of the network. With IoT, with mobile phones, with the networks that are supporting the gateways for the IoT, the wireless networks for, let's say, a 5G phone, and a lot of the processing to avoid latency has to be done out there, so that by the time you finish that, you really are sending up the data as close to possible in a streaming mode. And that's where the use of ELT versus ETL may make some more sense, but obviously we can't cover that all today. Um, I'm going to switch to a couple of other great questions here because I think we still have time for a couple more. So, Bill, one person here is saying, doesn't the person defining the things like the data cube have to know the warehouse structure to do the building?
I should hope so. Yeah, sure. But generally speaking, you have a technician build the cube of data, and then you have the end user using it. And most of the time, not all the time, but most of the time, those are two different people with two different skill sets. But yeah, I don't see how you can build an analytical cube or something like that without knowing the structure of the data warehouse.
Yep. Here's another question. can you talk a little more into unstructured data and the relevance of the newer object-oriented programming languages such as Python and others used to disseminate this data?
Well, that's a loaded question. I've spent the last 19 years of my life working on the problem of what do we do about unstructured data and data warehouses. And indeed, today we are seeing some amazing applications being built. Um, Two of them that come to mind are number one, medical records. Doctors write medical records and cast it in the form of prose. But inside those medical records, there is a tremendous amount of information and value. But a computer, the way computers are configured today, cannot take that prose and turn it meaningfully into a database, which means that the only way to do medical research today, if you're looking at prose, is to manually read it. And that automatically is a great barrier to doing medical research. If you're able to take text and put text into the form of a database, now you can use the power of database processing to look at millions of records when you do research. And that's just one application of what can be done when you take text and turn text into the form of a database. Another application that is waiting to explode is that of call centers. How many corporations have call centers? And the answer is most large corporations have call centers. And then how many corporations know what conversation is going on in their call center? And the answer is none of them do. And then you say, gee, don't you think it's important to hear what your customer is saying? Isn't that important information? And the answer is you better believe it's important information. But people don't know yet that you can go into your call center conversations, record them, put them into a database, and now you can sit there and say, gee, yesterday we had 4,000 calls, and the people were talking about this subject, or people were complaining about this, or people wanted to buy this. And so, the whole subject of taking unstructured textual data and turning it into a form where it can be analyzed is a well, I've spent the last 19 years of my life understanding how to do that. And I'll be more than happy to talk with you privately about it. But in the time we have today, I can only just give you the tip of the tip of the tip of the iceberg.
Yeah, and I just like to add one quick thing to that. So, Python is not a language that is only used by data scientists. Yes, data scientists, if you're a data scientist, the chances of you knowing Python approach deterministic. But believe it or not, most people coming out of college now in even business majors, my daughter's a 20-year-old at UC Irvine, and she's an accounting major. And the first thing she had to learn was Python. And you're going to see that used by people with the structured data as well as unstructured and semi-structured data. So for example, in any modern data warehouse, that's certainly the case for our data warehouse with Avalanche. There are user-defined functions that will enable you to use Python. All of the tools of all of our competitors, of complementary vendors in the ecosystem, allow you to get in and use Python. So let's not believe either Python is the realm only of data scientists, nor does it mean that somebody who's not a data scientist isn't going to play with unstructured data, particularly the metadata for it. So we've got 5 minutes left. I'm going to go just one last question that really goes to the basics. Okay. So Bill, this person saying, Did you describe how to automate the transformations? I heard you should, but how?
Well, that pretty much is up to the vendor. I mean, each vendor has their own way of doing that. So that I would have to shrug my shoulders and say that is a vendor specific question. And some vendors do it one way, some other vendors do it another way. And by the way, it can be, oh, certainly can be done. People do it every day. But as far as I can tell, there's no generic answer for that.
Yeah, and as a specific vendor, I'll give you a specific answer to that as we close out here. Our fundamental belief is that data integration, because it is such a huge portion of the time that teams, especially cross-functional teams, spend trying to prepare data and then get it into a, a data repository with the end goal really being the analytics tool or visualization or reporting tool that they're using, that whole process, you need to begin to remove IT. And the way to do that is make sure that that integration process can cover as many disparate and diverse data sources as possible in a way where they're not having to use programming. So yes, more and more people are using things like Python, but to grab data from all these different sources, the best way to do that is through some very simple guided GUI user interface with drag and drop menus so that you can actually remove IT from that process. And that's what we're doing with the Actian Avalanche, and specifically within the Avalanche Cloud Data Warehouse, the Avalanche Connect piece. So I want to just thank Bill for again providing us with gems of wisdom and a continuity of where things are going from the early days of data warehouses to this next generation as we move towards the modernization of cloud data warehouses. So, Bill, any parting words for all of the folks in our audience?
I just want to thank you for being here today and happy trails.
Thank you, Bill. Thanks, everyone. So this concludes our webinar for today. It will be available on demand. We will have a PDF of the presentation. And please take a look at some of my blogs online that really get into the future of where data warehouses are going and begin to pull together all of these other architectures. Have a great day.